Hi there, this is chapter 6.6, Inequalities in Two Triangles. So the essential question is, if two sides of one triangle are congruent to two sides of another triangle, what can you say about the third side of the triangles? What you will learn in this chapter section is compare measures in triangles, solve real-life problems using the Hinge theorem. Okay, another theorem. Okay, so what's this Hinge theorem they're speaking of? Let's take a look. This is theorem 6.12. If two sides of one triangle are congruent to two sides of another triangle and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. Okay, that's a lot to take in. So let's take a look here. We have two triangles. Vx is congruent to RT, VW is congruent to RS, and we know angle V is 88 degrees, and we know angle R is 35 degrees. So what the Hinge theorem is saying is if you have two sides that are congruent, and you know the angle measures of the two included angles, you can determine which side is longer of the two triangles. So if angle 88 is greater than an angle of 35 degrees, so therefore the side opposite XW, the length of XW is greater than the length of ST. That's all this is saying. Okay. And the converse to the Hinge theorem is just working it backwards, if you will. If two sides of one triangle are congruent to two sides of another triangle, like so, and the third side of the first is longer than the third side of the second, then the included angles of the first is larger than the included angles of the second. Okay, so it's just working backwards from this. So here we're given AB is 12 and DE is 9. And we're told that AC is congruent to DF and CB is congruent to FE. So therefore, if you look at the angle opposite right here, then we can now confirm from the Hinge theorem converse that angle C is going to be greater than, let me put a little curve here there so that we know it's or an arc. So we know that's not a less than symbol. Angle C is greater than, or I should say the measure of angle C is greater than the measure of angle F. Okay, because the side opposite's larger. So that's a Hinge theorem converse. Okay, so let's take a look at this. Okay, example 1 says to use the converse of the Hinge theorem. So it says given that side ST is congruent to PR, so ST is right here, PR is right here. It says how does the measure of angle PST, so I'm going to label that with one arc, compared to the measure angle SPR, which is right here. Okay, well, by the Hinge theorem, we need two sides congruent, but we have that PS is congruent to SP by the reflexive property. So now you should be able to see that in triangle PST, we have two sides congruent and an included angle that's opposite a side. And triangle PRS has an angle that's opposite a given side length and two sides. Okay, so it's obvious that 24 is greater than 23. So that means angle S or angle PST. So I'd say the measure of angle PST right here is opposite the side that's length 24. It's going to be greater than the measure of angle greater than the measure of angle SPR. Okay, and that's it. There's example 1. So now you should be able to do problem numbers 3 and 4. Okay, example 2, we're going to use the Hinge theorem. So they did the converse first. Now we're going to do the Hinge theorem. And it says given JK is congruent to LK. So JK is right here. It's marked congruent. LK is another marked congruent. It says, how does side JM compared to side LM? Well, just like the last problem, we have two triangles. Km is congruent to Km by the reflexive property. So now we have two sides and an angle measure that's included, and two sides that are congruent and an angle measure that's included. So I put two arcs on the 64 and one arc on the 61 because 64 is greater than 61. So therefore the side opposite is going to be greater. So I could say JM is the length of JM is greater than the length of LM. Okay, and that's it. The sides opposite are going to be greater when the angle's greater. Now I should be able to do problem number 7. Okay, example 3, proving the converse of the Hinge theorem. So now we're going to do a proof. It says write an indirect proof of the converse of the Hinge theorem. Okay, so it says we're given AB is congruent to DE. So there's 2 marks on those. BC is congruent to EF. Those have 1 mark. And angle AC, or I'm sorry, side AC is greater than DF. So AC is greater than DF. Okay, so how are we going to address this? Well, step 1, you assume temporarily that the measure of angle B is greater than the measure of angle E. So we're just assuming that this is greater than that. Then it follows that either the measure of angle B is less than the measure of angle E, or the measure of angle B equals the measure of angle E. Okay, I'm sorry, it says not equal or not greater than. So if you're assuming B is not greater than E, then they're either equal to each other, they're congruent, or E is greater than B. Okay, so that's step 1. All right, so we make an assumption. And then step 2 is if the measure of angle B is less than the measure of angle E, so if B is smaller than E, then AC is less than DF by the Hinge theorem. If the measure of angle B equals the measure of angle E, then angle B is congruent to angle E, and that would prove the triangle's congruent by side angle side, congruence theorem, and therefore AC would equal DF. Okay, that makes good sense. And then finally, step 3, both conclusions contradict the given statement that AC is greater than DF. Now keep in mind that we were given givens. We were told AC is greater than DF. So since AC is greater than DF, saying AC is less than DF is a contradiction. Okay. And it says temporarily assuming that B is greater than E cannot be true. This proves that angle B is greater than E. Okay, so we were given AC is longer than DF. Okay, so we have contradictions there. So therefore, the other thing is angle B cannot equal angle E because that would make AC equal to DF. And that's another contradiction is what this is saying. Okay, hopefully that makes sense to you. Make an assumption and it's kind of indirect as it's stated here. Okay. Okay, example 4, proving triangle relationships. Write a paragraph proof. We're given angle XWY is congruent to angle XYW, and they marked it in the diagram. And we're told that WZ is greater than YZ. So the first thing I'm going to do is just label this up. Let me use blue for WZ. So here's WZ, and I'll use purple for YZ. So these are the two sides we're talking about. And we know that WZ, the blue side, is longer than YZ, the purple side. But before I go any further, I can now conclude, whoops, go back to my pen. I can now conclude that since this segment here, and let's put a T here, XT is congruent to itself. Okay, we have an angle here congruent to an angle here. What else are we given? Let me think about this a second. We have an angle on a side now. Okay, so I'm a little perplexed on this problem, but I'm going to continue anyway, and we'll see where it goes. So we have this angle here congruent to this angle here, and I know that xt is congruent to itself. So I have an angle and a side in this triangle. I do not know that xw is congruent to xy. We weren't told the triangles are congruent. We weren't told that angle xy or xty or xtw are 90 degrees. So all we have right now is one angle and one side, and that is not enough to prove two triangles congruent. Okay. I don't have enough information to say that xy is congruent to xw. They did not tell us that. I do have two angles here that are base angles, if you will, that are congruent. So let me just think about this. If I have a triangle, and this is 40 degrees, and this is 40 degrees, that's 80. So this would have to be 100 degrees, and therefore it's an isosceles triangle. Ah, there it is. Okay. Okay, so they're not being very clear there, and sometimes we have to think these things through, but that's it. So let me erase this. It's got nothing to do with that. We have an isosceles triangle, xwy. So therefore, this side's congruent to this side. Okay. All right, so let's take a look. It says because angle xwy is congruent to xyw, side xy is congruent to xw because it's an isosceles triangle. By the converse of the base angle theorem, theorem 5.7. Converse of the base angle theorem. Yeah, from isosceles triangles. Okay. By the reflexive property of congruence, xz is congruent to itself. We got it. Okay, so that's angle side, and that's a side. So we don't have ASS. That doesn't work. So what do we have? XZ is congruent to XZ. Oh, that's the whole thing they're talking about now. So let me draw a line through there. So now we're talking about side XZ. So that is right here. Okay, actually I wanted that green. Okay, so XZ is congruent to itself. So because WZ is greater than YZ is what we were given, then the measure of angle WXZ has to be greater than, I'll put 3 marks, YXZ. I'll put 2. Okay? By the converse of the Hinge theorem. Okay, that one was a little tricky, but now it makes sense. It's an isosceles triangle. And voila. So now you should be able to do problem number 11. Okay, example 5 is a real life problem. It says 2 groups of bikers leave the same camp heading into opposite directions. Okay, so they're at a camp, they're heading in opposite directions. Each group travels 2 miles. So if they start at the same place, where am I? Start at the same place and go 2 miles opposite directions. They're now 4 miles apart. Then they change direction and go 1.2 miles. Group A starts due east and then turns 45 degrees towards north. Group B starts due west, then turns 30 degrees towards south. Which group is further from camp? Okay, so let me get rid of this. So here's a diagram. So let's talk about this again. Let me get my highlighter and make it a little thinner. Okay, so here's camp. And that's the wrong color to use, I guess. Use this one. So you start at camp and you go 2 miles like so. That's too thick. Try again. So here's the 2 miles east. Okay, group A starts due east and then turns 45 degrees and goes another 1.2 miles. The other ones left the camp and went, whoops, forgot to change my thickness, went 2 miles due west, turned 30 degrees and went in a southerly direction. Okay, so that's what we're talking about here. Which group is farther from the camp? All right, so what we're going to do here is, now keep in mind what chapter section this is and what we've been talking about. If this was 2 miles and this is 2 miles, then that is two sides that are congruent to two different triangles. Okay, corresponding parts of two triangles are congruent. And then this is 1.2 miles, and this is 1.2 miles. Okay, so those are equal. So now I have an angle here. Now, if this outside angle's 45 and this is a straight line, then this angle's a supplement to it, or 135 degrees. Because 135 plus 45 is 180. If this is 30 degrees, then this angle here is 150 degrees. So since 150 degrees is greater than 135 degrees and our distances are equal, then that means the distance from the camp, which would be right here, the distance from the camp here is greater than the distance from the camp to group A. Because the larger the angle, the larger the opposite side. So group B is further than group A from the camp. So this was just showing going east. This is north, 45 degrees towards north is in this diagram here. So what we're actually measuring after we're done is this whole distance here, which is 90 plus 45 or 135 degrees. Okay, so with that being said, group B is further from camp because 150 degrees is greater than 135. So now you should be able to do problem number 13 in the exercises. Okay, this brings us to the end of chapter 6.6, a nice short one for a change. And so I've assigned 25 through 28, which are review questions. So please do all these problems in your exercises. Thanks for watching and have a great day.